Installing a sub-panel in a garage can be accomplished without altering the existing 200 amp service. The process involves several key steps, beginning with identifying the appropriate feeder circuit. A feeder circuit rated for 100 amps or more in the main panel will supply power to the sub-panel. It is important to carefully select a sub-panel rated for the same amperage as the feeder circuit. For example, if the feeder circuit is 100 amps, the sub-panel should also be rated for 100 amps. The sub-panel should be mounted in an easily accessible location within the garage. Running the feeder cable requires installing an electrical conduit from the main panel to the sub-panel in the garage. Within this conduit, use THHN or XHHW copper conductors. These conductors must be rated for the amperage of the feeder circuit. So, if using a 100 amp feeder, the conductors should be rated accordingly. Next is connecting the feeder cable. Connect the feeder cable to the main panel at one end and to the sub-panel at the other end. It is essential to use appropriate connectors for these connections and torque them to the manufacturer's specified values. Following the cable connection, install a main breaker within the sub-panel. This main breaker should match the amperage of the feeder circuit. If the feeder circuit is 100 amps, install a 100 amp main breaker in the sub-panel. Regarding an outside disconnect, the National Electrical Code requirements vary by location. While not always mandated, it is strongly recommended for safety and convenience. An outside disconnect allows for de-energizing the entire sub-panel from outside the building, which is particularly useful during emergencies or maintenance. If choosing to install an outside disconnect, select a disconnect switch rated for the amperage of the feeder circuit. In this example, we would install a 100 amp disconnect switch. Mount this disconnect switch on the outside of the house near the location of the sub-panel. Connect the feeder cable to the disconnect switch first and then from the disconnect switch to the sub-panel. This configuration ensures the ability to quickly and safely cut power to the sub-panel from an external location. Several critical aspects should be considered when selecting conductors for the feeder circuit to the sub-panel. The ampacity of the conductors must be sufficient to handle the load served by the sub-panel, adhering to National Electrical Code Table 310.15b16 or other relevant tables for ampacity based on conductor type, insulation, and installation method. For a 100 amp feeder, typically 3 American wire gauge copper conductors or 1 American wire gauge aluminum conductors are used, but this depends on the specific insulation type and installation conditions. The grounding system for the sub-panel must be properly established. Isolate the neutral and ground bars in the sub-panel. Run a separate grounding conductor from the main panel to the grounding bar in the sub-panel. Do not bond the neutral and ground bars together in the sub-panel, as this creates a parallel path for neutral current, which is a safety hazard. Overcurrent protection is crucial. The breaker in the main panel feeding the sub-panel acts as the primary overcurrent protection. The main breaker in the sub-panel provides a local disconnect and additional overcurrent protection. Ensure both breakers are appropriately sized for the conductors and the anticipated load. Properly label all circuits in both the main panel and the sub-panel. This helps in identifying circuits quickly during troubleshooting or maintenance. Use a circuit directory to clearly indicate what each breaker controls. Use appropriate conduit and fittings for running the feeder conductors. The conduit protects the conductors from physical damage and provides a pathway for future wiring changes. Use appropriately sized conduit and fittings approved for electrical use. When connecting the feeder conductors to the breakers in both the main panel and the sub-panel, torque the connections to the manufacturer's specifications. These connections can cause arcing and overheating, leading to potential fire hazards. Use a torque screwdriver or a wrench to ensure proper tightness. Bonding refers to creating a low impedance path for fault current to return to the source. This is essential for safety, as it allows overcurrent devices to quickly trip and clear a fault. Ensure all metallic parts of the electrical system, including conduit, enclosures, and equipment, are properly bonded together. Before energizing the sub-panel, thoroughly inspect all wiring and connections. Verify that all connections are tight, all conductors are properly insulated, and all components are correctly installed. Use a multimeter to check for any unintentional shorts or ground faults. Once the sub-panel is energized, test each circuit with a load to ensure it is functioning correctly. Use a clamp meter to measure the current on each circuit and verify it is within the rated capacity of the breaker and conductors. Regularly inspect the sub-panel and all associated wiring for any signs of damage, overheating, or corrosion. Address any issues promptly to prevent potential hazards. Check for loose connections, damaged insulation, and signs of rodent or insect activity. Consider future expansion when installing the sub-panel. Choose a sub-panel with sufficient spare capacity to accommodate future circuits. This avoids the need to replace the sub-panel if additional circuits are needed later. If unsure about any aspect of the sub-panel installation, consult with a qualified electrician. Electrical work can be dangerous, and it is essential to follow all applicable codes and regulations. A qualified electrician can ensure the installation is done safely and correctly. When running the feeder cable, avoid running it through areas where it could be subject to physical damage or exposure to moisture. If the cable must pass through such areas, provide additional protection such as using rigid metal conduit or encasing the cable in concrete. Consider the load calculations for the sub-panel to ensure that it does not overload the main panel. Add up the anticipated loads of all circuits in the sub-panel and compare it to the available capacity in the main panel. If the sub-panel load exceeds the available capacity, reduce the load or upgrade the main panel. When selecting the location for the sub-panel, consider accessibility for maintenance and future modifications. Choose a location that is easy to reach and has sufficient space for working on the panel. Avoid locations that are obstructed by equipment or stored items. Ensure the sub-panel is properly grounded to protect against electrical shock. The grounding conductor should be sized according to the National Electrical Code Table 250.122, based on the size of the overcurrent protection device. Use a green insulated conductor for the grounding conductor. When making connections in the sub-panel, strip the insulation from the conductors carefully to avoid nicking or damaging the wire. Use a wire stripper tool to ensure a clean and consistent strip. Damaged conductors can overheat and cause a fire hazard. Use only approved connectors and fittings for all electrical connections. Do not use wire nuts for connecting large conductors, as they may not provide a reliable connection. Use mechanical connectors or compression connectors that are specifically designed for the size and type of conductor being used. When installing breakers in the sub-panel, ensure they are properly seated and securely fastened. Loose breakers can cause arcing and overheating, leading to potential fire hazards. Use a screwdriver to tighten the breaker screws to the manufacturer's specified torque. Protect the sub-panel from moisture and corrosion. If the sub-panel is located in a damp or corrosive environment, use a weatherproof enclosure and corrosion-resistant hardware. Apply a protective coating to all metal surfaces to prevent corrosion. When working with electrical wiring, always turn off the power at the main panel before starting any work. Use a voltage tester to verify that the power is off before touching any wires or components. Follow lockout/tagout procedures to prevent accidental energization of the circuit. Wear appropriate personal protective equipment when working with electrical wiring, including safety glasses, gloves, and insulated tools. Avoid wearing jewelry or other metallic items that could come into contact with live wires. Do not work on electrical wiring if feeling tired or distracted. Electrical work requires focus and attention to detail. If tired or distracted, take a break or postpone the work until feeling more alert. If encountering any unexpected problems or challenges during the sub-panel installation, stop work and consult with a qualified electrician. Do not attempt to troubleshoot or repair electrical problems without proper training and experience. Keep a record of all work performed in the sub-panel, including the date, description of work, and materials used. This record can be helpful for future maintenance or troubleshooting. Consider installing surge protection in the sub-panel to protect against voltage surges that can damage electronic equipment. Surge protection devices divert excess voltage away from sensitive equipment, preventing damage. If the sub-panel is located in an area where it could be exposed to physical damage, such as from vehicles or equipment, install bollards or other protective barriers to prevent damage. Ensure the sub-panel is properly ventilated to prevent overheating. Do not block the ventilation openings in the enclosure. If the sub-panel is located in a confined space, consider installing a fan to provide additional ventilation. If the sub-panel is located in an area where it could be exposed to flammable materials, such as gasoline or propane, take precautions to prevent ignition. Use explosion-proof enclosures and wiring methods. Consider installing arc fault circuit interrupter size breakers in the sub-panel to protect against arc faults, which can cause fires. A size detect arc faults and quickly trip the breaker, preventing a fire from starting. When installing wiring in the sub-panel, follow the National Electrical Code guidelines for wire bending radius. Bending wires too sharply can damage the insulation and reduce the ampacity of the wire. Use wire markers to identify each conductor in the sub-panel. This makes it easier to trace circuits and troubleshoot problems. When tightening screws and terminals in the sub-panel, use a Torx screwdriver or wrench to ensure proper tightness. Over-tightening screws can damage the components, while under-tightening screws can cause loose connections. Inspect the sub-panel regularly for any signs of water damage or corrosion. Water damage can cause electrical shorts and corrosion can damage components. If the sub-panel is located in an area where it could be exposed to extreme temperatures, use components that are rated for the appropriate temperature range. Extreme temperatures can affect the performance and lifespan of electrical components. Consider installing a ground fault circuit interrupter GFCI breaker in the sub-panel to protect against ground faults, which can cause electrical shock. GFCIs detect ground faults and quickly trip the breaker, preventing electrical shock. When installing wiring in the sub-panel, avoid running it near sources of heat, such as furnaces or water heaters. Heat can damage the insulation and reduce the ampacity of the wire. Use only approved wire sizes and types for all wiring in the sub-panel. Using undersized or unapproved wire can create a fire hazard. When connecting wires to terminals in the sub-panel, ensure the wires are fully inserted into the terminal and securely fastened. Loose connections can cause arcing and overheating, leading to potential fire hazards. Inspect the sub-panel regularly for any signs of rodent or insect activity. Rodents and insects can damage wiring and components, creating a fire hazard. If the sub-panel is located in an area where it could be exposed to dust or debris, use a dust-tight enclosure to prevent dust and debris from entering the panel. Dust and debris can interfere with the operation of electrical components. Consider installing a tamper-resistant cover in the sub-panel to prevent unauthorized access. This is especially important if the sub-panel is located in a public area or an area where children may be present. When working with electrical wiring, always follow the National Electrical Code guidelines and local electrical codes. These codes provide minimum safety standards for electrical installations. If unsure about any aspect of the sub-panel installation, consult with a qualified electrician. Electrical work can be dangerous, and it is essential to follow all applicable codes and regulations. A qualified electrician can ensure the installation is done safely and correctly.